Okay, we are going to do a problem, a real world problem right here. What happened to this? What's going on? I don't know what's going on. I wanted to try to highlight something, but that's not working. So here's our problem. Okay, Claire's test average in her world history class is 90. Okay, that's her test average in her world. So when she added all her tests up and averaged them out by dividing by how many tests there are, her average was 90. The test average is 2/3 of the grade. The final grade for the homework average is 1/3 of the final grade. So homework is like 1/3 of your grade, while the tests are 2/3. So I like to think about candy bars when I think about like this type of thing. Let's say this is a candy bar, and this candy bar has test parts and then homework parts. Well, in this situation, 1/3 is homework, and then 2/3, this is 1/3, and then 2/3 is test part. Tests. Okay, so we know that of this test part, she's got 90% of that. Why? Because she didn't get 100% on all her tests. But that's pretty good. 90% is really good. What we want to figure out is on this homework part, how much of this homework does she need to get so that the grade at the end is at least 93%, so that her grade, her final grade is 93%. She wants that A. That's her goal. That's great, and it's a good goal to have. So let's start up a little problem here. This is kind of how you can put this together. It's kind of nifty. Really, what you do is this 2/3 times the 90% and 1/3 times this x. We need that to be greater than or equal to the 93. Okay. So one more time, 2/3 of this 90%, that's what she got on the test, because the test was 2/3 weighted grade. So of 90 plus 1/3 of whatever she's needs to get on her homework, because that's 1/3. The homework's weighted 1/3 of who knows what she needs to get. This added up together has to be greater than or equal to 93%. Okay, because she wants to get that A. So now we need to solve for this x. Okay. So right away I look at this and I kind of freak out, and the reason I freak out is because these fractions are here. But you know what? We can get rid of these fractions because they're both 3's, and I know that if I multiply everything by 3, every one of these terms by 3, these fractions, they will go away. Check this out. So I'm going to multiply this whole thing by 3. Remember, whatever I do the one side, I got to do the other. This whole thing by 3 and this whole thing by 3. I'm kind of doing this railroad track thing, right? So when I do that, I didn't multiply by -3, so this inequality sign stays the same. Check what happens. Okay, this 3 cancels out these two 3's down here, and then this 3 just gets multiplied by that 93. So what I have now is I got 2 times 90 plus 1 times x is equal to 93 times 3. That is 279. Okay, 279, I think. I apologize if it's not 279. So let's just do a little multiplication. 2 times 90 is 180. This is plus just an x, because 1x is just x, and that's 279. 279. Okay. Let's subtract the 180. This is the last step. Subtract the 180. These are, remember, these are still less than, greater than, or equal to signs. So subtract the 180. We have x is greater than or equal to, what's 270 minus 180? 99. That's 99. Okay. So what did it say? For her to get 93% in class on her homework, she has to get a grade of either greater than or equal to 99%. That's what she has to get on her homework to get this final grade in this class. So this is just, I think, you know, just a refresher. Pictures, candy bar pictures are kind of helpful when you're dealing with some of these things. Just to set these things up. You make a candy bar and then think about that. Okay? There we go.